talking too much, so that's kind of a positive side. I got more caffeine because I didn't think I was going fast enough. So now let's get into a little bit into the API. All right. So from a actually, you know what I'll do? Maybe I'll just go straight into writing some code. And what I might do is steal the chair because I don't think I have to actually look at the screen. And I apologize for people back there, who can no longer really see me, but I'm not all that much to look at anyway. Alrighty. So I'm going to pull up. Oh, I almost forgot to give a plug here. A plug to Danny Coward, who's the specification lead for WebSockets, and this is the Kindle edition of his Java WebSocket programming book. So basically, it goes into everything I've talked about in a much more friendly way. And it's from the spec lead. So, alrighty. And I think what I'm going to do is bring up Netbeans. Yes, I am using surprise. Since it bundles GlassFish, it's kind of hard not to. As you can tell, I've done this. Well, I don't think you can see. The actual code I'll make bigger.
Really can't see.
Yeah. Don't worry about the mechanics of the Netbeans project pane over there. I'll make the actual code larger. Sorry. Hopefully the connector won't fall off again. This is my OC Echo application. It was just brought up that everyone seems to do Echo applications or chat applications. It's just so easy, right? Because the point is the API, the point isn't the functionality. And besides, I'm not a developer, I'm a product manager, so it's about as far as my brain will take me. Okay, so we're going to create a GlassFish, a Java project. Not open, I want to create a new one. And we're going to use Maven, and I'm going to create just a vanilla web application. And I am going to call this SDJUG directory. Let's see, we'll call it SD Echoes. Right?
Yeah.
Oh, okay.
That's much
And it's going to deploy to GlassFish 4, and it's a Java EE7 web profile project. All right, so I could choose if I wanted to. Oops. Actually selected the project itself as being web profile. But if I select Java EE6, it's not going to work because it's only available as Java EE7. Alrighty. Come on now. Let's create a project. I wonder. Yeah, that's actually not a problem with Netbeans. It's the fact that I think I'm running JDK 8, kind of by accident here, I think. It actually created the project, and I'm just going to open it. Oops, one, SDJUG, and there we go, SD Echo. Okay, this is basically just a blank project. There's no class files or anything. So, to actually create a WebSocket endpoint, what I'm going to do is just use a generic Java class, create a generic Java class, although there's also the ability to create a little wizard to create a WebSocket endpoint, but it doesn't do much, and you'll see why here in a second, because it's pretty easy to create a WebSocket endpoint. So we're going to call this class Echo. Make sure everything looks okay. All right. So this is just a okay, can everyone see that? All right.
So it's just Pojo and the decorated
Yep.
annotations?
Yep, that's it. At server endpoint. And then the relative URL, which is going to be Echo. And at this point, we basically have a WebSocket endpoint. Right? Now, the question is, what do I do? How do I handle connections? So, there's basically callbacks for each type of those events I mentioned before: error, on message, on open, on close, right? And to specify which methods are called for each of those events, well, first of all, you only have to define the ones you care about. So if you don't care about errors, if you don't care about opens and closes, and only the message, then we can just create non-message. Actually, on message, and we're going to basically say public, return a string, oops, echo string, return string. Right. I have to import, fix the imports there so it imports the on message. And basically, this class is now a WebSocket endpoint. And anytime it gets a request and a string is passed to it, it's just going to return it back to the client. And that's the end of my presentation. Thank you. Okay, and now I'm also going to cheat here a little bit because I'm not the JavaScript.
Question.
Yes. Is there a question? Yes.
What types are going to be natively or intelligently supported as like return types?
So this is an area I'm not too familiar with, but there's a slide on this. There's actually multiple text types. Oh, here we go. So strings, Boolean, bytes and byte buffers. You can, if you want to, you can get the input stream for that connection, use an input stream and read and write whatever you want, right? And then you can pass all kind of data types back and forth. But
so
just in terms,
receive JSON type.
sorry.
Can't receive JSON.
Oh, you're playing right into my hands. I'm going to actually show you how one way of handling it with JSON, and partially because I just want to show you a little bit about the JSON API and Java E7. So how many people here actually use JSON right now in their apps? Okay, pretty much everybody, which is expected.
Just right back here.
Oh, yes.
How come I don't see integer?
Because the core API only understands strings and bytes, right? Remember that the API is actually very low level, and it's up to you, the developer, to define the protocol going back and forth. So if you want to send an integer back and forth, like, you know, you can either do it via JSON and parse it, right? Or you could probably get it as an input stream. Yeah. Well, if you look at the JavaScript side, right, of the API especially, when you make that call, JavaScript knows about basically bytes and strings, right? And passing it over WebSocket. That's pretty much what your options are in terms of the WebSocket API on the JavaScript side.
But they did go ahead with Boolean.
Yeah, there's so Boolean, and like I said, you can get a from the Java.
Well, it does
The
say
Java
Java
EE side.
primitive though,
Yeah.
so that would be the integer.
Doesn't that cover all your number
Yeah,
types? There you go.
reader, Java primitive. Good
Okay.
question. So
So maybe integer is supported.
yeah, well, you know what? We can
Or-
try it.
Or capital integer.
Yeah, we can try it. I apologize. Anyone from the Coucho folks know? Out of curiosity? Okay.
Int should be supported because Java primitive, right? So
Yeah.
I
So
didn't see that.
I got okay. So we can actually try it out. That's the server side. Now, one of the things I'm going to do, because I'm not a JavaScript developer, I'm going to cheat and just copy and paste the actual browser code in. All right? I'll show you the JavaScript code here in a second. So if you look at the JavaScript side, this is where you actually make the connection, right? So Okay, just making sure everyone can see in the back. It's good enough size. So you notice, first of all, you specify the connection using WS : which is the WebSocket, and then off to the URI. You make a connection to that URI, and you store it in the WebSocket variable. And then what you can do basically is, in this case, for each event, on open, it'll call this function, right? On message, it'll call this function, right? Which we then just delegate to local JavaScript functions. And on error, it'll call on error, okay? And it's pretty simple. When it disconnects, it prints out disconnected. If you click the disconnect button, it'll actually call close. It'll close the WebSocket and then say disconnected. On open, it'll print out it's connected. On a message, it'll write the message to the screen, and on an error, it'll say, hey, there's an error. And then there's a doSend method that actually sends some text from the client to the server. Okay, WebSocket.send, and then some message, which is just text. So if I actually, oops, and one thing I'm going to have to do is make sure the URL is right. It's not EchoJug, it is, I think it's SDJUG, what I called it?
It was all lowercase.
Is it all? I'm going to double check here real quick. It is, oh, SD Echo. Oops, sorry. Capital E or lowercase e? Capital E. There we go. Let's go ahead and run this. And down here, it's starting up the app server and doing everything it needs to do. Yeah. Alright, that is the JDK 8. I think. Where is it? Oh, hold on. You know, I just did this and everything worked just fine. Okay, so. Tell you what, let's go to a known state. Stop the app server, I'll just reboot. Not that I should have to. I also didn't want to start it in okay, there's the app. So if I want to bring it up in Chrome, do that. All right. So, what we're going to do is basically just send some text. Bigger. There, can you see it? All right. What we're going to do is basically send some text to the server. So connect is going to make the WebSocket connection using the WebSocket call, basically instantiating the WebSocket. Disconnect will basically call WebSocket.close and then WebSocket.send. So let's try and connect first, and hopefully it works. Connected, so it actually connected. And what I'm going to do is basically now just send some text, send hello WebSocket, and got back hello socket, and just let's make sure that it's all working fine. So let's modify the string and return message.
Can you open the debugger on the browser? There's much JavaScript.
Window. Sorry, it's been a while.
F12?
Well, thank you.
Not on a Mac.
No, the Mac.
Oh.
Right. It goes about 2 megs of memory. Okay.
It's Control-Alt-L.
What was that?
Command-Alt-L.
Command Alt. Yeah, you know, I have this one. View. Here it is. Hold on. View developer. JavaScript
So
console?
if you right click and then inspect, it'll bring that.
Okay. So what did you want to look at?
If you run it, I think when I've done some work with WebSockets, it throws some stuff into the console. If that's
Okay,
right.
so let's do this, connect.
If you bother.
Nope, disconnect. Well, I'll tell you how I tend to do it.
Yeah.
Settings of the console.
But you have to put the console,
Yeah.
on the console. and
Yeah,
then
it pops it up.
Here. Here's what I'll do. In Netbeans, which is, I tend to do it through Netbeans, but obviously you can get a lot, from a client perspective, going through the local debugger is good. Uh-oh, come on Netbeans. Crash bang. Okay, let me try this here. Let's do a force quit. Yeah, I'm not sure how I started it up. Try to create a .np.sh to point to JDK7, which is actually tested and supported. And if worse comes to worse, I'll just pull up Netbeans 7.3. Note, beta.
Not trying this at home, proper instructions.
All right, okay. So, let's go back to the project. All right, let's do pull that open, doesn't really matter. And now we'll connect, and if I send a message, now it says write message below. So it did what we said it would do. Now what's interesting is, a lot like JaxRS, since a lot of folks here have done some JaxRS development, you can actually create custom message handlers. Right, and the web, it's kind of interesting because the WebSocket API, in a lot of ways, is kind of modeled after JaxRS, right? So we kind of learn from the JaxRS folks. So one of the things that you can do is if you want to, for example, pass JSON back and forth, then we can basically create a custom handler that will handle JSON code. Now, out of curiosity, what JSON parser is everyone using? Like Jackson, Json. Okay. Let's see. So, what something new to Java EE7 is a Json Processing Api. And what's interesting about that API is it's intended to layer over existing implementations. It's not another implementation of a processing. Of a JSON processor. It's intended to provide a standard API layer on top of existing implementations. So if you look at the actual API, there's only one concrete class in the entire JSON API, and everything else is like interfaces. Right? So it's up to these providers to actually plug in their implementation into the standard API. The RI is another implementation, but the intent is for Jackson and Json and all these others to actually plug in, and you, the developer, can write to a standard API. And there's ways within the JSON API to call down to or configure the underlying JSON processor, right, with specific settings if that's required by your application or by that library. And the idea is you write the application once, and then maybe you pick a JSON processor either based on how fast it is, how little memory it uses, right? But the idea is that you can plug in different processors. So, one thing that we can do is if you look at this server, oops, wrong one. There we go. Is we can provide a decoder or multiple decoders. In other words, you can have multiple types of messages coming in on the same socket, and you can have multiple message decoders that know how to decode that message. And same thing with encoders. You can encode messages in different formats depending on the client that you want to talk to. Okay? So, in this case, we're going to define a coder. We'll just call it Java decoder class. And it's basically going to say, hey, there is no such thing called Java decoder. If you want to create it, yes, because we're going to create our own Java decoder class to actually decode the message. So we're going to do this with JSON, just to show you a little bit about the JSON API. Create class in the package, SDJUG. Oh, interesting, it says OCJUG still. Sorry, I don't mean to offend anybody. Okay, so this is just a generic Java class. And now what we can do is extend decoder. We'll see, where do they go? Just called decoder. Dot text. That's not what I meant. There it is, right on top. Decode. Dot. Hey, decode exception. Decode. Where's the WebSocket? So, here we go. Let's do this. If all else fails, go back to the previous one that worked.
It's not an interface? Gee! Decoder.text. Thanks, the text in the mail. And we're going to decode a string. And this is an interface, too much caffeine, that we're going to have to implement all the abstract methods. All right. So we're going to take a look at what some of these methods are that's in the interface. There's basically 4 methods in the interface. The first one is decode, which actually decodes the message and passes it back to the application. Another one is called will decode. What this basically does is it allows you to look at the message and decide if this is the kind of message that you can decode. And if not, you return false. If it is, then they'll basically call the decode implementation, the decode method. Init and destroy are just lifecycle methods. So if you have to set something up and tear it down before and after the decoding, then there's the opportunity to do that. Now, if I recall correctly, the encoder and the decoder classes, I think those have to be reentrant. I think there's only one instance of those that are shared across all the connections. But if you look back at this echo class, there's actually one instance of this echo object per connection. Or sorry, per request. Right? But the encoder and decoder, I believe there's only one instance of it. Right? Which is why we have an init and a destroy. Okay. So, let me go back and actually do some code here. So let's basically do nothing here. And here we'll just do nothing. Will decode, return true, or else it'll be a very short presentation here. And format. And the actual decoding itself. So what we're going to do is basically use the new JSON features that's in Java E7. So there's basically a JSON reader, a JSON input stream. Basically, you're gaining access to an input stream, right? And from that, you can do your JSON parsing. The JSON API actually has two types of parsing. It's very similar to XML. You either have a streaming model or a DOM-like model. In this case, because it's easier, we're going to use a DOM-like model just to show. Let's just call it reader. Let's see, JSON reader, reader equals JSON. This is that one concrete class I was talking about. It's basically a class that has a bunch of factory methods, right? That will rely on the underlying implementation to actually create all the right instantiations of the underlying frameworks. Equivalent code, I guess, or features. So JSON dot create reader. And we're going to create a reader. This is an input stream. So I think what we want to do is apologize. This is when we go back to our other example. Is it byte buffer? Sorry. Yes, thank you. Buffered input stream. Ew. Okay. R0. Sorry, I am buffered input stream. Oh. No. What am I doing wrong? Sorry. Too much caffeine again. Byte array, yes. Hold on. Tell you what, this is the easiest way of doing it is to cheat. Can't remember what I did. Did I open the same one? Let's do this one. Project. Oh.
You like to see, don't you?
Yeah, well, yeah, I'm just trying to figure out why, project, sorry. I'm working off of about 3 hours of sleep. Right there. Source. JSON decoder, byte array input stream, string to get bytes, that's what it was, sorry. So pretend you didn't see that.
I think
Yes. R0. Hey, do you guys want to write this? Alrighty. Whoever thought that this would be a team effort, right? This is like pair programming gone wild.
We call it mob programming.
Yes, mob programming. There we go.
Bytes has to be called.
Okay. So we have to add the imports.
Extra parentheses.
Yeah, too many params.
Lisp.
And you need to move one of the parens after arg0. Oh no.
No.
Oh, you're right.
I think we're okay there.
Yeah.
All right. So now that we have a reader, what we can do is basically reader dot. Actually, let's do it this way. JSON object obj equals reader dot read object. Fix the import.
So basically, the JSON object in the processing API is the underlying implementation will read the entire JSON object and store it in an internal data structure that you can basically then access through a map-like interface, right? So in this case, we're going to say return obj.getString, we'll call it message, right? So it's going to get the method, if you look at the key value pairs inside the object, which you'll see in a second, the key is message, right, and obviously the value is whatever we pass in through that text field in the web page. Now if we go back to our index.html, let's take a look at message colon. Here it is. Send. Here it is. So this is the code. Yeah, this is the code that basically sent the message before, whatever was in the text field it just sent. This time we're kind of manually converting it to a JSON object, right? Which is just open squiggly brace, message colon, and then the message, right? So the key is message, the value is whatever's typed into the field, right? So this is a JSON object. Right? Now, everything here should be okay. Okay, place your bets. Oops, wrong one. Wrong window. All right, so let's try and do a connect. And send, and disconnect. So,
You didn't get that.
I think I didn't.
You need to refresh?
Yeah, let's refresh the page.
Yeah.
Connect, send, disconnect. Okay, let's look at this. Let's look at our Java. That'll return true. This, just to be that way.
Can you go to the
Yeah, I was going to go into the bugger next. That was the next step. But I thought I'd just do a clean and build first. Okay, connect. Send.
There we go.
And disconnect. So this just gave you an example of how you can use a message handler to handle messages. So you can imagine that when you begin creating your own custom protocol going from the client, between the browser and the server, you can actually write your own message handler by using decoders and encoders to encode using whatever your own protocol is, right? But it's fully under your control to do that. Let me see here. This one? Yeah. Let's see if there's any other, it's too small. Let's see if there's any other interesting, oh, one thing I forgot to bring up. Since there's lots of JaxRS developers here, I thought one thing I would talk about is path parameters. So WebSockets also has, sorry, it's in here somewhere, also has the concept of path parameters. So for example, you could pass in, here, let's see if I can just show you. Let's go to our echo object.
heck of it. Then here, add param. Here, oh, put
This
down.
is for me.
Just, well, yeah, just name plus, oops, plus string. Just trying to show something here that uses a path parameter. Now this should automatically redeploy. Now what's going to be interesting here is if I try and do a connect, it's not going to work because it needs one more part of that path param. Do a connect, dagnabbit.
Is that your compiler?
What was that?
On your path parameter, it's got a red line.
Oh, it does. Well, that explains it. So it didn't even. See, you guys are much more alert than I am. Oh, duh. Sorry. I said, which path parameter? Ta-da! Okay. Now that should automatically redeploy. Let's do it. Just do a page reload. Connect. Still connected. Test. No.
So you ran in the OC echo,
Oh, I did.
no, the browser.
Oh,
That's what.
Yeah. I'm offending everyone again. Okay. So there we go. Go ahead. No wonder I got too many browsers open. So connect should fail. Okay. Now let's switch this. We have to go into the actual code, and we'll just hard code it for now. Go into the index.html, and where we connect, let's just say SDJUG. Back, reload the page, connect, that's how it connected, send, SD echo, okay, got that right. SD echo, SDJUG. You know what? Based on the prior point, let's make sure we have the right decoder. Oh, sorry, echo. Make sure I was editing the right echo class. And I was, okay. Name, string name, there's the name. This should work.
Maybe another Cleveland drill?
Yeah, that's, great minds think alike. It should come up in Chrome this time. That didn't pull, correct. Send, see, that doesn't sound right. Let's do this. I'm curious. I'm curious as to why it's not pulling, there it is, why it wasn't pulling the browser to the front. Okay, connect, send, disconnect. Is there a bug in the Java code? Return name plus string. Oh, sent, there's no receive. Connected name. Let's try this. So now we'll go into debug mode. I'm sure this is how you wanted to spend your Tuesday evening, debugging my poor programming.
This is reality.
This is reality. That's true.
So,
Yeah, I'm working off basically like 3 hours of sleep because we have deadlines for Java 1, working on like keynote slides and stuff like that, and I am living on Starbucks right now.
Can I see your endpoint in JavaScript?
Can you see what?
Endpoint,
The endpoints. You mean the actual connection?
in the JavaScript.
So let's do this. Go back to the Java code. Echo, SD echo, echo, SDJUG. So this should be the name path parameter, right? That looks okay. All right, so
Was there a port error on the app server?
was there?
Like address and use or something pops up briefly?
Yes. Yeah. You ran that twice.
Okay, let's go look at the super log.
I think it was 1527 that there was.
Not able to set the breakpoint.
No,
That one?
Not that, no.
This one? No, that's okay. There might have been past errors that are just stuck in the log.
Okay.
So let's try it. So let's do a connect. Oh, okay, let's try something a little bit different. I'm going to be somewhat similar applications. So undeploy them. And stop. And code and redeploy. Let's do it the old-fashioned way. If this doesn't work, I'll probably just punt and say I need to get some sleep. Okay. So let's go back to. Ooh, I didn't mean to do that. See, I'm still fighting lack of sleep. Okay. Let's see if we can confuse GlassFish. Okay. Now connect. Wait, it's not supposed to do that. All right. Well, pretend it worked. I don't want to sit here and spend the entire time debugging, but so one interesting question came up during the break, and that was so when to use WebSockets versus like JAX-RS calls, right? And if you want, we can turn on the lights, or I can. Here, gotta warn us next time. So just kidding. So we, and that's an interesting question, right? So just keep in mind that the JAX-RS model is request response, right? So if you want to be able to proactively and asynchronously send a message from the client, from the server to the client, without having to make any kind of request from the client to do that, using long polling or whatever, then it's a natural candidate. And the more often you do that, right, the more WebSockets becomes an option. Another is if you want simultaneous communication back and forth, because it's, I mean, it's truly asynchronous in that sense, just like a regular IP socket is. Low latency. So we brought up a use case. If you can think about a first-person shooter in the browser, that is actually a very good use case for WebSockets because there is no parsing of the HTTP headers, right? So it's actually much lower latency. And I forgot, someone had done, there's a blog entry out there kind of adding up, sending, something like hello world, right? And the amount of overhead for HTTP, the connection, sending the bytes and all that kind of stuff, it's like 20 times bigger than just sending hello world, right? Because there's so much overhead in HTTP. And with WebSockets, the latency is like a tenth or a 20th of the latency of running HTTP. So if you have something that's sensitive to latency, like a first-person shooter, or maybe if it's a professional online trading system, right? Then using WebSockets seems to be a pretty natural use case. And if you want to, and another interesting one is if you're sending, binary formatted data between the client and the server, like a video, custom video format or something. A WebSocket sounds like a pretty interesting solution to that as well.
So those are just some of the use cases that we're bouncing around. You can do much more than echoes and chats, which is what you typically see, but you typically see them because it gets the point of the API across and doesn't focus on the actual business problem of the API. Are there any other questions? Yes?
Is there any spec or being talked about how to put more security on this WebSocket? Because it's a nice feature if you're not dealing with financial information going
Right.
back and forth. And if you work in a bank or any of those, whatever company you're working for requires encryption, HTTPS communication, this is not gonna work.
Well, but just,
Now, once your endpoint is HTTPS, actually.
Yeah.
You tunnel through that one.
yeah, you can connect with HTTPS.
Yeah, in the beginning, but you said once it's
Once
done,
it's established,
it's
well, actually, thank you for bringing that up, because I should clarify that. Once the connection is established, if it's over HTTP, that connection is over HTTP. If it's over HTTPS, that connection is gonna be secure.
Oh, okay.
It'll be encrypted. So actually, I'm glad you brought that up. I wanted, that's an important point, is that the communication between the client and the server is basically over an SSL encrypted connection at that point.
Oh, okay.
Yeah, yeah. But like I said, the authentication, all that stuff is gonna happen at the HTTP layer. And if you need more than that, again, it's something that you have to write yourself using the WebSocket APIs.
Okay.
WS and WSS, is that the thing?
Yeah, WS is a cleared connection and WSS is a SSL encrypted connection.
So you can use WSS under ACT.
You would use, that's a good question. You probably could start out as HTTP and convert over into WSS. But then you're mixing and matching unsecure and secure code in the same web page, and one of the browsers is gonna warn you, hey, you have, or vice versa, right? I don't know. I'd have to think about that one. But generally, what you'll do is you'll connect over over a secure connection, so people know before you type in your password it's a secure connection, right? So it naturally probably start as an HTTPS connection anyway.
So the promotion is natural between HTTPS and WSS. You don't have to do anything extra or manual.
Correct. You just have to specify WSS
Yeah.
in your actual
And you
connection.
said the same certs and everything that came for the ride with HTTPS to begin with. It started the transaction, right?
Well, what's interesting, I believe with the WebSocket protocol, I know you can do it with JAX-RS. You can gain access to any cookies during the handshake aspect. I'm not sure if the WebSocket API will let you do that, right? So there's something called an endpoint config object, and that provides configuration information. I'm not sure if you can get access to any cookies that were established as part of the actual handshaking connection. But generally speaking, if me, John, connects to a server, I would do HTTP, and then it would know I'm John at the HTTP level, but as soon as you switch over to WebSockets, I'm not sure how that principal information gets passed on to WebSockets. Again, I think that you can get to it through, one of the things I didn't show you is, with onMessage, I didn't show you onMessage, onOpen, and onClose, but with onMessage, you can actually pass in a couple of extra objects if you want them. Let's see, the bigger, sorry. It didn't go all the way. Oh, it's because I'm in debugger. Just go to the other. Okay, here we go. So you can also pass in a session object. WebSocket session. And with the session object, I can get I don't know if you guys can see this at all. I can get access to the remote client, so I can send messages back to the client. What you saw here was just return, but you can get an access to the session object and send multiple messages back to the client. So you can kind of keep a reference to the remote client. If you think about a chat application like a chat board, when someone sends a message, you want to broadcast it out to everybody else. So what you'll typically do is you'll have some sort of set or hash map or whatever that stores all the sessions. And when someone sends a message, you basically iterate through that collection and send that message out to everybody else, right? And the way you do that is with the session object, you can get basic remote, basically lets you get a connection to the remote client, and then you can send messages back to the client. And get async remote, actually you can send messages asynchronously. So you send the message, you don't wait for it to be put onto the socket, it just sends it and returns control immediately back to the calling thread. So it's basically like non-blocking. Let's look at that. Returns a reference asynchronously to the peer, right? So it'll send the message, but it won't block. Let's see, and then there is another class, Endpoint config. You can get a list of all the encoders and decoders that are registered. Get user properties. When a connection is established, you can actually store some information in that session object, basically using like a map, right? So if there's something interesting about that connection, if you think about the path param, like someone connected with a name. So if you connect to a URL echo/John. Right. If you want to, you can store that path param John in this property, in this property map, and then when you want to make communication back down to the client, you can leverage the information in that map. So it's specific. It's a lot like an HTTP session object in that sense, right? So you can store information across requests if you want to, conveniently. I don't see a way to actually get access to cookies. Sorry, that's what I was just looking for. It actually stored it as part of the handshake process. So, sorry, I digressed. Any other questions? Yes?
Yeah, how do server endpoints deal with like idle connections, or when the client crashes? Does it just release the resources or times out?
No, in memory leaks.
Okay.
I know, I'm kidding. I just wanted to roll every time. No, that's actually a very good question, because that gets to the on error. Well, actually, if the client closes, I don't think that's going to cause an error message. I think it's going to call on close. And then you, as a developer, if there's any resources that you were holding on to as a part of that connection, then you can close them, right? So it'll call close. It's just like typically with any other, I'm trying to think of like IP sockets. It's been so long. Well, I don't know if it matters, but I think it's, in the case of a failed client, it will call on close.
But when does it know that it's a failed client?
Well, because the socket will close, right? And so the underlying infrastructure, like in the case of GlassFish, Grizzly, which manages all the connections, knows it closes. And then, because the client crashed, and then it'll pass it up the stack, and eventually it'll call on close. Again, I think it's on close versus on error. The other thing, let's see, the other thing you asked about long-lived connections. And what's interesting about that is, right, if you think about proxy servers in between, right, they may want to kill long-lived connections. There's actually, I mentioned that ping and pong frame. So there's actually, in the API, you can actually send a ping and send a pong back as part of the API. It's actually part of the WebSocket spec. So you can verify that a connection is still alive. But the other thing it does, right, is it shows there's traffic on the network. So maybe if there's anything in between the two sides that you know, if it sees no traffic, it closes the connection, you can use ping and pong frames to keep the connection alive. Yes?
How does it work in the low bandwidth environment?
How does it work in low bandwidth environments?
Load balance.
Oh, load balancing. Good question. So, good question. So, the load balancer is going to have to know about WebSockets, right? Because most load balancers, they, like HTTP load balancers, they'll either use a cookie to know which server on the back end to send it to, or they'll insert a header inside the HTTP header. The load balancer will use the HTTP header, store some data there, and then when it goes back and forth between the browser and the server, I think using the HTTP header, it knows where to go to. I think it's what WebLogic does. So it plays with the HTTP header. In the case of WebSockets, my guess is that because it's no longer an HTTP connection, it's just an IP connection, the load balancer is going to have to know about WebSockets. So like Oracle Traffic Director, which is basically a traffic management product that runs on Oracle's XLogic systems. It knows about WebSockets, and it knows how to load balance WebSockets. I don't know what other load balancers support WebSockets, right? So does mod proxy, or from a Java perspective, or I have no idea right now what actually supports WebSockets, but now you got me thinking. See, the interesting issue there is when the connection is initially made, right, there's a handshake. So you do have cookies and you do have HTTP headers. And you have a long-lived connection. So there might be a way for, I suspect that that's how WebSocket proxy servers deal with that. So the client connects to the server, the client connects to the load balancer, and then the load balancer is going to have to somehow maintain that connection and that relationship to the right back-end system. So I think it has to be designed in. That's my guess. But I don't think you can use a generic load balancer with WebSockets. I think it's going to break.
It becomes sticky to one node.
Yeah, it becomes sticky to one node, but the question is, how is that stickiness maintained, right? And I think it's because, well, typically in a stateless environment, which is HTTP, right? It's all done via, like I mentioned, cookies or HTTP headers, or whatever. They play games that way, but you don't have that across, with the WebSocket. But what you do have that's different is you have a long-lived connection, right? And so when you first connect, you know who the connection is coming from, and that's a long-lived connection. And then using your load balancing algorithm, you're going to connect to one of the servers on the back end. That's a long-lived connection, and that's a persistent connection end-to-end, right? The question is, if this guy fails, what happens? Right? Does it fail over? Does it return an error back to the client? In other words, is it an HA kind of load balancing, or is it simply just load balancing for load? I suspect load balancing for load is easy, and load balancing for HA is much harder. So you've stumped the monkey. I think that's my way of saying I don't know the answer exactly, but I was speaking more hypothetically. Yes. Any other questions? Alrighty.
I think that's it.
Yeah.
Thank
All right.
you.
Well, if you have one of these back from the Wayback Machine,
The Wayback Machine, yes, official
They do?
member of the Java user group.
there you go.
Do they still send these out?
No, they don't.
They don't?
Private collection.
Well, thank you very much. I appreciate it.
See,
That's his way of saying, please come back and present when I don't have any presenters, right?
There you go.
But I'll be happy.
Right. Well, thanks again, John. It was a really good show.
Thanks for inviting me and thanks for listening.
Thank you to the select group for the pizza and sodas tonight. so that's it for another exciting month in the San Diego Java Users Group. We'll see you next month for